Hey guys, welcome to question FM339 of the Further Maths Fortify study guide. This question reads, Chris is going to use a soft drink can to hold his pens. He will remove the top of the can so that his pens can stick out. The dimensions of the can are shown in the figure below, and then we're given a figure that looks like this one. The can has a diameter of 7.5 centimeters and a height of 12.5 centimeters. Question A then asks us, what is the surface area in square centimeters of the inside of the can, not including the removed top? Round your answer to the nearest square centimeter. So essentially what we'll be finding is the area of the circle that makes up the bottom of the can, and the area of the rectangle, which sort of makes up the cylindrical sort of shape of the can. So we'll be looking for the area of a circle, and we'll be adding the area of that rectangle to that. Now, if you are familiar with the surface area of a cylinder formula, you're just removing one of the circles from that formula, but I'll show you how to build this up from nothing. So the first shape that we're dealing with is the circle that makes up the base of our soft drink can. So the formula for this would be pi r squared. Of course, in this diagram, we've been given the diameter of the can, not the radius. So plugging 7.5 divided by 2 in your calculator should let you know that your radius is going to end up being 3.75. And we'll leave that as the expression for the area of our circle at the moment. Next, we'll be looking for the area of our rectangle. So we know that the formula for the area of a rectangle is just length times width, or length times height, however you want to break that down. We know straight off the bat that one of the dimensions of our rectangle is this 12.5 centimeters high. And we're going to use the circumference of a circle to figure out the other dimension of our rectangle. So we're used to dealing with 2 times pi times r. So we get 2 times pi times, and then like we saw down here, the radius that we'll be working with is 3.75. So combining our circle and rectangle, adding them together, we should get, for our area, we should have pi times 3.75 squared plus 12.5 times 2 times pi times 3.75. Plug that all into a calculator, and if you've rounded to the nearest square centimeter, you should get 339 centimeters squared. And that's your answer to part A. Part B is a little trickier conceptually, but pretty easy to break down. So we're told after this that to organize his smaller utensils, Chris will build smaller cans with half the total surface area of the above soft drink can. The soft drink can and small cans are similar. What is the volume in cubic centimeters of the smaller cans? Round your answer to the nearest cubic centimeter. So the information that we've been given here, we've actually been given a scaling factor. Now the hugely common mistake that will come out of this question will be mistaking this for k equals 1 over 2 instead of acknowledging that this is going to be k squared equals 1 over 2. Now, because we're using a scaling factor that's using an area, we've got to acknowledge that this scaling factor is a squared scaling factor, just like what we're going to actually use in this scenario that I'm creating is going to be taking our single scaling factor, or for our one-dimensional lengths, the scaling factor for this, which involves square rooting both sides, which means that if k squared is 1 over 2, k is going to be root 2 over 2. So if we wanted to find the dimensions of our new can, our small can, we would take this root 2 over 2 and multiply that by each of the dimensions of our current can, and we'd be given those new dimensions. So with this in mind, we're going to remember that to find the volume of this small can, if we were to just use if we had the dimensions of our small can, we would just use the formula pi r squared times h. In this scenario, the radius of our small can is going to be this transformation applied to the old radius of 3.75. So our new radius is going to be root 2 over 2 times 3.75. And our new height is going to be root 2 over 2 times 12.5. Substituting these two values back into our volume equation for the small can, we're going to get that our volume is equal to pi times root 2 over 2 times 3.75 all squared, and we're going to multiply that by root 2 over 2 times 12.5. Plugging that all into a calculator and rounding to the nearest cubic centimeter should land us at an answer of 195 centimeters cubed. So if you guys have any questions about any of these questions, please leave a comment in the comment section below. Otherwise, I'll see you in the next video.